This panel discussion is on grid of the future. Now, why are we talking about grid of the future? We have been for centuries, ever since Industrial Revolution, have been using all kinds of fossil fuel for energy. The primary being petrol, gas and coal. We all know that with the increasing consumption, if the consumption was small, probably it wouldn't be as serious a problem. But with the increasing consumption, these are the primary cause of GHG emission and global warming. Of course, as was pointed out in the earlier session, that the number one cause is that our consumption is increasing. In fact, Anson should show that graph. In last 250 years, our consumption has kept on increasing exponentially and still continues to do so. So if that happens, no technology will be able to solve it. But assuming that there will be some letting down on that, the basic task is to replace the fossil fuel with renewable sources of energy, primarily solar and wind. Now, in Indian context, to give you a picture, the solar based electricity cost only 2 rupees per minute, per kilowatt hour. Wind costs 3 rupees per kilowatt hour. If you use coal to generate electricity, and suppose we set up a new plant, it will cost you 4 rupee 50 paise per kilowatt hour. If you use gas, it will cost you 15 rupees per kilowatt hour. And if you use petrol or oil, it will probably cost you 35 rupees per kilowatt hour. And remember, our diesel generators actually use petrol in India quite a bit whenever power goes off, and it costs you 35 rupees per kilowatt hour. So one will say, it's obvious that we should all move to solar and wind, but it's a lower cost and it's also renewable, does not hurt the environment. What is the primary reason that it doesn't happen? The primary reason is that solar and wind cannot be controlled. Whenever God wishes, sun is out there and we get the solar energy. If a cloud comes and tries to hide the sun, the energy goes down or completely goes down. Similarly, when wind is blowing, we get the electricity. When wind stops blowing or blows slowly, electricity is not there. So essentially, generation cannot be controlled by human being, and therefore solar and wind will be available when the sun and wind is available. So it is not 24/7. In itself, it does not match the demand. The demand can be at any time. What if enough solar or wind-based electricity is not there? And at some other time, there is a lot of solar and wind and it is producing electricity, but the demand is not as much. What does one have to do? What can one do? Remember that energy once generated either has to be consumed immediately or just goes waste. So what are the options with us? One is to use energy storage. Can we store the energy in some way or the other? That helps, because then I can always use it some other time. There are batteries in which you can store the energy. You can actually heat cold water or warm water if you are going to use it later. You can do that and store water. There are other forms of storage. If you have a dam, you can pump the water up back and then pump the water back down and generate electricity. So that is, storage is one form of handling the intermittency of renewable energy like solar and wind-based electricity. The other form is to have a grid. Because when sun is under clouds at some place, sun is not under clouds at some other place. If sun is out some other place and not there some other place, maybe wind is there. And for example, very simply, when early in the morning we have enough sun, we have sun from maybe 6:30 a.m. till around 6:30 p.m. But after 6:30 p.m., we don't have a sun. But since our German Consulate General is sitting next here, I can say Germany is some distance away. When at 7 p.m., 6 p.m., 7 p.m., it is 2:30 out there in Germany, or probably even 1:30. And that time sun is at its peak. If there was a way to transmit that energy here, we could use it between 7 to 10 p.m. quite easily, 11 p.m. quite easily. Similarly, when late in the night for them, maybe early in the morning for us, and we may have solar energy and they may not. So if you make your grid, and if you can put the grid across the world, then somewhere or other solar and wind will be available. Is that an impossible task? To put a electricity grid across the world? It looks impossible. But I wanted to point out that I was born in a much earlier era, not close to you. Way back in late 70s, when you used to communicate, telephone communication, there was no internet. One way of communicating across between different countries was through the satellite. And that's a time, late 70s, my earliest work was on what is called optical fiber. You can actually put thousands of voice calls into a single fiber and you could carry it from one place to another. So we are doing it on the ground anyway within the country. By 81, 82, we started doing it. But somebody came with the idea that can we not lay these cables under the water and connect the continents? We started working on this. It looked impossible. It really looked impossible. Extremely difficult, cost is extremely high. But we did not give up. 20 years down the line, 2000, we had something like 10,000 fibers going across the world. As a result, telephone communication from one country to another became very, very easy. Today, for example, if you use WhatsApp, you don't even pay for it, except your connection charges. Internet came up and became across the world. And those optical fiber underwater, tens of thousands of such cables exist and is carrying voice. Therefore, I want to point out about the grid. The grid can today look impossible, particularly worldwide grid may look impossible, but it's a matter of time. 10 years, 20 years down the line, you will have a grid across the world. And energy from one place will be carried. And therefore, if there is no sun or wind at some place, sun and wind will be there at some other place, and from there the energy can come. Now there are lots and lots of issues which I like the panelists to start answering. How difficult it is, how expensive will it be? Can you really, does it really make sense to put this grid? First, on the land, can India and Middle East be connected? Can India and Thailand and India and Vietnam be connected? On the land, can it go all the way to Europe and go at least up to France or Norway? What does it take? And then what does it take to take it underground and connect this, and what will it imply? This is the subject of the discussion, because this becomes alternative to energy storage, and it's critical for the renewable energy to flourish. I'll request both the panelists to give their opening remark for about 7 to 8 minutes, and after that we will start the discussion. Sir, Senapati.
Yeah. First of all, I think Professor Jhunjhunwala has said the context very rightly. And today we'll see India is going to touch around 500 gigawatt by 2030. And definitely, grids has to be very robust. And India has done a lot of in that. So if you'll say, India has done green energy corridors for the evacuation of the grids. Today, India is building huge HVDC networks to evacuate the renewable power from the generation to the load centers. And India is also nicely connected, interconnected across the SAARC region today. SAARC means hydro is coming from Bhutan to India. Thermal is going from India to Bangladesh. Then we have a proposal also. India has a plan to connect under the sea to Sri Lanka also. So the region-wise or continent-wise, some sort of interconnection to connect to ASEAN from India. Plan is to connect to Middle East grid, Middle East. And in the Africa and Asia, there is some connectivity to the northern Africa side. And Europe already connected few areas, that part of the world. So more or less, and it's all through underground cables, basically, HVDC cables. So more or less, things will be getting connected across. So one part of the world, if the solar is there, other part is not there, then it can be pumped there to the other part of the world. So that few things are already in place, few things are being planned. So that is basically the interconnection of the grid. Then I'll talk about the greening of the grid. So it's all intermittent, grid is getting very unstable. So what are the interventions are being done to make it stable, operational, and efficient? Okay. So few of the things I think I'll talk, or like you can say, inertia of the grid, managing the inertia of the grid, managing the contingency analysis, contingency of the grid, redundancy for a reliable power, and few of the technical intervention which will come later. And third is the resilience of the grids. Today, a lot of natural calamities are happening. We have seen Los Angeles fire, wildfire. So how we can manage that? How we can manage the grid? The huge hurricanes and cyclones. How we will manage the grid? So grid as such I can categorize like is all interconnected grid, is the greening of the grid, and the resilient grid. These three categories I can categorize. So if you'll see, basically greening, a lot of renewables are getting injected there, and there is a disturbance in the grid, and it's all intermittent. So it varies based on the sun intensity and the wind capacity, all those factors. So, and you will see earlier, we are not getting any, a lot of inertia from being generated from the thermal and hydro plants, which is not being supported by the renewables. So those monitoring, like PMU-based monitoring, PDC-based monitoring, we can do that. Then second is, today, I'm talking a bit of forecasting. See, today we have a day-ahead forecasting and all, but we do not know what particular point of the day there will be sudden cloud appears. So like Saudi, we're all being done in a single place in a gigawatt scale. So if you'll see, all of a sudden there is a cloud. So 3 gigawatt is out of the radar. Then there's a grid imbalance. So that sort of, to manage those sort of solutions, the local forecasting is very important. Okay, so which few things L&T is doing there, a local cloud-based, camera-based cloud forecasting. So this is one of the good things being done. Then, if you'll see, rightly to manage the grid, you need to have your quality power delivery to the grid efficiently. So like power front controllers and all, which India also started deploying. And storage definitely is required when there is no sun, there is no wind, storage come into play. And also it comes into play during your peak time management, peak hour, peak load management, and renewal smoothing. So those are the applications definitely in place. And some of the things, I think, storage side, Rahul is here. I think he is very much involved. And we heard all 26 onwards, it starts getting deployed. So I think things are getting grounded, and it's a good thing. Today, if you'll see, few plants like around 6 gigawatt is being done by Aqua there in Middle East today, Saudi especially. And today they are putting all the storage there to back their renewables, or else it will of no use. So that is that important. And one most important thing everybody forgets. Having all these things, you need to have a contingency planning, you should have a grid compliance study, you should have a system study. Because until unless you don't have that in place, then you can't do a correct setting. What I require, what grid setting. People will, their setting approximately will happen that way, this way. So it should not happen that way. So you should be putting the setting near to the study parameters. So that will help to avoid the fault. The fault may happen, but the clearing the fault will be instantaneous, immediate. So those sort of things we need to really look into. So those are the interventions are required. Some of the I mentioned, so that will help the grid be stable. And one more is that reactive power compensation. Basically, India started doing that, like STATCOMs and all. So that helps in a big way to make your grid greener and stable.
Okay. Thank you. Thank you very much, Suvendu. We'll now ask Sharon Fernando. Now, before he says that, and I think he will certainly say that, but one, Sri Lanka is our neighbor, very close to Tamil Nadu at least, and almost looks like you can hop onto that place. One of the problems with Sri Lanka is that Sri Lanka does not have any coal. So therefore, India has on the other hand enough coal, and most of our electricity, almost 50-55% electricity is still coal-based. Now, since Sri Lanka has no coal, it cannot generate coal-based electricity. So conventionally, how has it been generating electricity? By using oil, gas, etc. And now, of course, a little bit of solar and wind. And remember that oil and gas are so expensive. And if the electricity as a result is very expensive, the industry suffers like anything. So Sri Lanka has a huge problem of electricity. But on the other hand, India has a large electricity infrastructure today. Its usage is only about 55 to 60% of its capacity. 40% of our plants are idling, or each plant is working at a reduced capacity. If there was a grid between Sri Lanka and India, not a very long one, if we can connect the two, then Sri Lanka's problem will, our city problem will be solved. And for India, the fact that many of the plants are bleeding because they have to either reduce the total production or reduce the total production or shut it down will revive. So in that context, request you to please, Sharon Fernando, to say a few words.
Thank you very much, and thank you to the Research Park for inviting my colleagues and myself from DILMA. We are very concerned with the whole question of sustainability and so on. That we've been energy sustainability. We've been working with IITM and Professor Junjunwala's team. Let me, Professor Junjunwala has contextualized the question. Let me give you a little bit of Sri Lankan context. But before that, given the sessions we've had before us, the problems are people, the solutions are people, and I will tie that up at the end of my answer. So the whole economic crisis happened in Sri Lanka, and we're very thankful to India for the bailout because it was a really, really bad time for us, and the $4 billion you loaned us really sort of made our lives livable. But the reason for that economic crisis was about 40 years of negative fiscal deficits and 40 years of negative trade deficits. Now, in countries like Sri Lanka, India, in countries like ours, fiscal deficits are not as easy. Economists will tell you that you have to tax more and all of that, but in reality, it's not so easy to do. And therefore, what's important is to export, the strategy of Vietnam and so on. You need to improve your exports and have a trade deficit and use that to cover your fiscal deficit for sustainable economic development. As Professor Junjunwala said, our energy prices, we have about 30% of our grid in hydro, which is cheap, but the balance 60% or so, 50 to 60%, is thermal, and that too expensive thermal. Largely diesel, some heavy diesel, and so what happens is our industry suffers, and when our industry suffers, our ability to be competitive in the export industry suffers. And we spend about $3 billion a year in total fuel, in total import of fuel, which is a significant percentage of our total imports. Now, on some very rough numbers, if we could connect grids from Sri Lanka to India, the first thing that would happen is Sri Lanka is estimated to have about 14 gigawatts of wind power in the eastern part of the country. The 14 gigawatts of wind power would be, $3 billion approximately in terms of sales revenue. So this is a country with a $10 to $12 billion export, $3 billion. I mean, you're talking almost a 30% increase in export revenue on that only. If we could, through grid connectivity, achieve a 20% reduction in our energy prices, which on high-level sort of study seems possible, that should bring to our industry a 10% increase in productivity, which could bring us a 5 to 6% saving in overall production costs. So the question of competitiveness will definitely happen. If any of you have visited Sri Lanka as a tourist, say for 10 days, you'll find that your most expensive cost in the 10-day tour is your car hire, because fuel is expensive. So the connectivity of the grid could, in short, bring us long-term economic sustainability. The problem, ladies and gentlemen, is unfortunately people. I mean, just as much, I'm going to be blunt here because we're in an academic environment and I can say it straight. I mean, as India, you understand problems with China because of borders and sensitivities and, all of that geopolitics you understand. Now, similarly, Sri Lanka and India, whilst we have 2,500 years of friendship, brotherhood, I mean, very, very similar cultures, there have also been, little skirmishes along the way. And we need to overcome the geopolitics and the people attitude to enable the grid connectivity, because the rest of it is very easy. It's something like 30 kilometers. It costs, I think the estimates are at about roughly $1.2 billion, which is, in relation to what we spend on fuel, not very much. So I wish we could, and if we are connecting grids, we should also connect road and rail, and this could really unleash the economic potential of Sri Lanka. Thank you.
One of the things that I have learned over years is that when we are talking about new technology and bringing in a new technology, of course, on the land, grid connectivity is not a new technology. It's a well-known technology. Companies are doing it. It's economically viable. The cost of my getting electricity here in this office already takes into account the cost of the grid. But when one talks about underwater links between two countries, between two continents, then the cost is certainly that needs to be understood. So as I was pointing out, what I have learned over the years is that when you start working on a new technology, first work on a top level economics of it. Now I'm talking about top level economics. You may not understand every piece of the cost. Estimate. Estimation is extremely important at that stage. Build a model based on estimation and say, at this cost, this is what the situation is. And if you are able to therefore reduce cost here and here, it will become economically viable. That gives you the places that the technologists need to work in reducing cost. So yes, India-Sri Lanka distance is very, very small. India-Thailand distance is not all that small. Since one is talking about grids being connected in India to Middle East, what do you think the economic impact of putting a grid between India and Sri Lanka?
Thank you for that question, Professor. I mean, like I said, I think it would enable us to gain about $3 billion extra in selling renewable energy to India. It would enable us to get overall base load support from India, which should bring a 10 to 20% reduction in our overall energy cost. So that's a reduction in cost of living, plus it is a reduction in our overall production. That increase in productivity will have a snowball effect over the whole production side of the economy to make our exports from tea to everything else so much more productive. I mean, let's talk about tea. At the moment, the country uses about 40% of our total energy is from biomass, and a good percentage of that is from tea. So what we're doing at IITM is looking at new technology based on heat pump to try and decarbonize that. But that decarbonization on top sort of high-level numbers would reduce our cost of production by about 30%. 30% can make our tea 10% cheaper in the market, very competitive against Kenya. So like that, every industry will gain an additional competitiveness.
So this is a top, very, very top level. And I think this is something that you are able to state today. You could have stated it 5 years back also. But things have not moved. The reason why it has not moved, in my opinion, is because you have not gone down to actual economics of laying a cable under the sea, and what will it cost, how does that project itself work. Is there work on what the cost will be, what is the reason for that cost, and can that cost be reduced? Once again, I'm asking you.
Professor, I think the Indian side of it has done the study. I have seen the study. I haven't read the whole thing, but 1.2 billion was...
I'm interrupting. I know Indian side, and maybe he will have more. But what we have done is simply collected the cost from across the world and put it. We have not looked at where can the cost be reduced. So I will now request Senapati to continue.
just give
I have,
an,
however, I will add one more twist to Senapati's thing.
Yeah.
So far we are talking about underwater link, but I am even talking about now on the ground link.
Yeah.
I am told that if I put a solar plant at some remote location, and then I put a grid to come to the, let's say, some city or something like that. Since solar is going to generate electricity, its peak electricity generation is only 5 hours a day, though it may actually do it for 12 hours. The remaining 19 hours, so it is equivalent to carrying 5 hours of peak capacity. If you create 100 megawatt grid, it will carry 500 megawatt because that's all that will be generated. But a 100 megawatt grid should be able to carry 2400 megawatt. So actually, the cost may become 4 to 5 times. And that is the reason the solar plants and wind plants at distance locations is not coming as much. I think you know that very well. So not using grid 24/7 is a big problem. Can you comment on that?
See, actually, when this green energy corridors are being planned with the funding from ADB, KFW, madam is here. So basically, that challenge has come. What is the ROI? So daytime it carries and nighttime minimal, as Ashok mentioned. So, but India started doing a mixed use. Okay, create the capacity, use the peak hours, whatever there of the solar, off peak hours, bit of, I can say solar or night times the wind, and the regular thermal or nuclear, other things you start transmitting. So that way you can justify the utilization of the grid. So that way it has started. Okay, but now also it is same. The condition is going on. But now when you are adding the utility scale storage, then it has to discharge, then it has to carry. So then due to that also night time, off peak time, the grid also bit loaded. Maybe the thermal and nuclear, that loading has come down bit. So that way it has being planned now.
And can you comment on India-Sri Lanka grid?
Yeah, Sri Lanka actually, not only India, Sri Lanka, I always see the subsea level. So the technology has not changed really for last few years. Okay, why technology has turned? The demand is not there. Okay, so conventionally, like few Japanese, few Scottish, they started manufacturing all the subsea cables. So real technology has not changed. When the requirement has now come, the requirement really is coming, not the interconnection. Interconnection is already there. We're planning, but the offshore wind. So when you're taking the offshore wind to the shore, you require a subsea cable, but that supply chain is not still there. So supply chain is not there, few players are manufacturing, technology intervention is there. So by virtue of that, the price levels are a bit high. So you have to depend on them. Now, things are changing, and when the technology intervention will happen and the demand goes, then like solar sometime back, it was 14, 15 rupees and all. So slowly with technology changes and the adoption level increasing, things has changed to today what we are now. The similar way it will happen. So the adoption level goes, the demand goes, the supply chain improves, the technological intervention happens, then it will come to a level where you can really afford, I can say. Today it's not, okay, we are doing for the sake of doing, you can say, offshore renewable, okay, that price is also very high. So that will come down, okay. So that's all my thought on that. And interconnection, when it is going to in a big scale, then things will slowly change.
So I think we are coming close to the end, but my final question, and I would like both of you to address. One of the strength of India has been when it goes deep dive into any area to takes 5 years, 7 years, but significantly reduce costs. Now when it significantly reduce cost, things which are otherwise looking economically unviable starts becoming viable, and that changes the whole scenario. Do you think both for the overground grid as well as for the underwater power grid. And the underwater power grid is going to be probably high voltage DC grid. Is it possible for India, industry and academia, and to work together to significantly reduce the cost and make the thing viable?
Yeah, I think a lot of interventions are already done technically. So today, if you see overhead transmission line, the two major costs goes to the right of way. So that's a big thing. So today, you have the same line, same transmission line, but due to improved conductor, like you can say HTLS conductor, it carrying more power in the same line. So you need not to replace same tower and bit of modification of the tower, and with the different conductors, it's carrying more line. So there's an intervention already is being done in India due to the ROW. So one point is addressed. Then I think if you'll say, I think that is one of the major reasons is being avoided. First of all, it's not of the cost. You get stuck up there. So for years to complete a transmission line to the ROW. I think that is one of the important factor. Other factors is being, you can say the technological side, you build a lean tower. So your foundation will be lean and tower is lean. So your per megawatt cost comes down, your civil cost comes down. So you get a competitive edge on that. So I used to work on a lot of things on the disaster side. So I always, this time, okay, it should be very minimal, wind impact will be less. So those things are in a different coastal zone it comes. But I think these 2-3 interventions, we can reduce the cost drastically. It has already been done to a greater extent, but still there is a lot of scope for improvement.
Fernando.
Okay, in answer to my question, may I place the question back? Using Malaysia and Singapore, the road connectivity, it has helped both countries significantly in terms of their economic development, and there is no threat to Malaysia or to Singapore through the connectivity. In that context, and given that it's only 30 kilometers, Professor, does the connectivity for electricity have to be undersea? If we have road connectivity, can it not be overland?
Once it's a road connectivity, it can be overland. So thank you very much, both of our panelists. I think the only point that I am making is working on the grid, making it stable, and extending the grid all over the earth is certainly the future direction. Sooner we are able to get there, better it is. Thank you. Thank you very much.
Thank you for that wonderful session.